Yes, they look very similar, but the way that we actually rationalize the denominator of these two expressions are totally different. So what should we do? Look at the first one. We have 1 plus the cube root of 2 plus the cube root of 4 in the denominator. So we can first rewrite the denominator as 1 plus the cube root of 2 plus, as we know that 4 is the square of 2, so in fact we can rewrite the last term as the cube root of 2 quantity squared. How does that help? Well, now we need to use the following formula, which is a to the third power minus b to the third power. And we know that this is factorable because we can try to set this equal to 0 and find out that in order to factor out, we need to have a as equal to b. In other words, a minus b is a factor of a cubed minus b cubed. And for the other factor, we'll of course get a squared plus a times b plus b squared. Now if we try to let a be 1 and b be the cube root of 2, we will now get the following. On the left hand side, we have 1 to the third power minus the cube root of 2 to the third power. Where the right hand side, well, for the second part, this is exactly what we have in the denominator. So what we are missing is just the a minus b term. So what are we supposed to do? We can now try to multiply both top and bottom by a minus b, which is 1 minus the cube root of 2. And of course, we need to do the same thing on top, which gives us the following. If we multiply the denominator, we will now get 1 to the third power minus the cube root of 2 to the third power. And in the numerator, of course, we just have 1 minus the cube root of 2. And as we simplify the denominator, we will just get 1 minus the cube root, and the cube will be cancelled, which is 2, to give us 1 minus 2, that is negative 1. So multiply the negative 1 to the top, we get the cube root of 2 minus 1. So for the first expression, we need to use the formula of the difference of cubes to help us rationalize it. Next, if we look at the second expression, can we do that? Well, we cannot, because now instead of having the cube root of 2 as a second term, we have 2 copies of it. So in this case, we need to change our strategy a little bit. So we can first rewrite it as 1 plus 2 times the cube root of 2 for a second term, plus, well, for the last term, we again have a 4, which is the square of 2, so we can rewrite it as the cube root of 2 quantity squared. And what do we notice? We have 1 plus 2 times something plus something squared. And again, that means we actually have a perfect square if we try to factor out. So it means that we have 1 plus the cube root of 2 all squared in our denominator. What should we do next? Of course, if we have this, we should actually try to multiply the parts that actually give us no cube roots anymore. How do we get it? We have to use the other formula, a cubed plus b cubed, which is a plus b times a squared minus ab plus b squared. And again, if we try to multiply this, we'll be able to get just the cube of A and cube of B, where in this case our B will be the cube root of 2, so that as we raise to the third power, they will be cancelled out. And that's how we rationalize it this time. And therefore, we need to multiply the fraction by 1 minus 1 times the cube root of 2, which is the cube root of 2 itself, plus the square of the cube root, which is the cube root of 4 in this case. And since we have 2 copies in the denominator, we need to multiply with 2 copies as well. And ladies and gentlemen, we now can just simplify our denominator by multiplying them together, which gives us 1 to the third power plus 2 to the third power, all quantity squared. And that is 1 plus 8, which is 9, squared, which gives us 81 in our denominator. Last, we just need to multiply out if you want, or you can just leave your answer on top, because our goal is just to rationalize the denominator. That's it.